We often hear that time travel is impossible. But is it? Well, maybe not in the way you think. In fact, we know from Einstein's theory of relativity that time travel is possible. But to do that, you need a spaceship capable of traveling close to the speed of light. This effect has been proven by experiment. It's called time dilation. In this video, I will show you what time dilation really is with realistic animations of fast-moving spaceships and astronauts aging differently than people on Earth. Let's start with a simple thought experiment. Imagine two identical twins, Bob and Bruce. They look the same, have the same DNA, and they even have the same birthday. But when they turn 20, they decide to do different things. Bob chooses to stay on Earth, but Bruce decides to take a trip into space. Bruce finds a job as an astronaut working for NASA and is sent on a mission to Proxima Centauri, the nearest star to our Sun. The mission takes 8 years to complete, and during that time, Bruce ages at a slower rate than Bob due to the effects of time dilation. After 8 years, when Bruce returns to Earth, he will be younger than his twin brother Bob, who stayed on Earth. This may seem like science fiction, but it's actually a reality. It's been proven by experiment. Here is what happens. Due to the equivalence principle, an astronaut in a spaceship far away from any gravitational pull feels no gravity. If there are no forces acting on an object, it will move with constant velocity. That means if Bruce maintains constant velocity, he will keep moving forever in a straight line. This is what happens if Bruce travels at 99% the speed of light. He will be moving incredibly fast, and after 8 years he will be only 4 light years away from his home. But since he is traveling at 99% the speed of light, for him only 8 years will have passed. But back on Earth, more than 20 years will have passed for Bob. And here is a visual demonstration of what just happened. We will use a space-time diagram where time is measured on the vertical axis and distance is measured on the horizontal axis. The diagonal lines represent the path of light. Since nothing can travel faster than the speed of light, the astronaut cannot travel this way. To demonstrate the effects of time dilation, let's start with the moment Bruce leaves Earth. We will use a blue line to represent Bruce's path through space-time. The green line represents Bob's path through space-time. Bob stays on Earth so he doesn't move in space. Therefore, his position in a space-time diagram is represented by a vertical line. Now, let's simulate the journey of Bruce by moving his blue line at an angle relative to the vertical green line. The angle between the two lines represents the speed of the spaceship. The closer the spaceship gets to the speed of light, the steeper the angle between the two lines becomes. Let's keep going until Bruce returns home after 8 years. Now let's see how much time has passed on Earth. We can read the time elapsed on Earth by measuring the vertical distance between the two lines. In this case, over 20 years have passed on Earth. So when Bruce returns home, he will be younger than Bob. So is time travel possible? Yes, it is possible. You can travel into the future by traveling at a significant fraction of the speed of light. However, you will need a spaceship that can withstand the extreme g-forces involved in accelerating to such high velocities. And currently, we don't have such a spaceship. But in theory, it is possible. In the next video, we will explore faster-than-light travel and see if it is possible. Thank you for watching, and I'll see you in the next video.